Today's lesson is 4.4, least common multiple, also known as the LCM. A multiple is found by the result of multiplying a number by an integer. For example, if we were asking you for the multiples of 3, it would be 3, 6, 9, 12. We got those numbers by doing 3 times 1 is 3, 3 times 2 is 6, 3 times 3 is 9, 3 times 4 is 12, etc. It will work with your times tables, and that's how you can tell that they're multiples. All right, your least common multiple is the smallest whole number that is divisible by each of the given numbers. 2 or more numbers are what we work with. This year we will work with 2 and 3, and as you go along with your math career, there will be times you do 4. A reminder, when you're doing the least common multiple, it means that it needs to be at least as big as the largest number. Okay, let's do a factor ladder to find the least common multiple of 6 and 8. We draw our ladder and find a prime number that goes into 6 and 8. Well, the prime number that goes into 6 and 8 is 2. 2 goes into 6 3 times, 2 goes into 8 4 times. Is there a number besides 1 that goes into 3 and 4? And the answer is no. Since there is no other number that goes into 3 and 4, your prime factorization is done. Now, when we did GCF, your GCF was found by using the number that you divided by. Your LCM is found by multiplying all of the numbers on the outside of the factor ladder. So for this problem, your LCM would be 2 times 3 times 4 equals 2 times 3 is 6 times 4 is 24. So 24 is your LCM. Now, we have the numbers 4 and 5. Again, draw your factor ladder. Is there any number that goes into 4 and 5 besides 1? And the answer is no. The only number that goes into 4 and 5 is 1. So that tells us that the way we're going to find our LCM is by taking the two numbers that we have and just multiplying them together. So in this case, your LCM is 4 times 5, which is 20. So your LCM of 4 and 5 is 20. Now let's do one for 12 and 20. What I would like you to do at this point is pause the video and give yourself a couple of seconds to solve the problem before you go ahead. Okay, the smallest prime number that goes into 12 and 20 is 2. 2 goes into 12 6 times, 2 goes into 20 10 times. Is there another prime number that goes into 6 and 10? Yes, 2 goes into 6 and 10. So 2 goes into 6 3 times, 2 goes into 10 5 times. Is there another prime number that goes into 3 and 5? The answer is no. That tells us that our prime factorization is finished and that these are the numbers we're going to multiply in order to get our LCM. So your LCM on this problem is 2 squared times 3 times 5. Well, 2 squared is 4, 4 times 3 is 12, and 12 times 5 is 60. So your LCM is 60. So when using a factor ladder, the LCM is the product of all the numbers on the outside of the ladder. Okay, now we're going to do a factor ladder with 3 numbers. This one is pretty simple, but there are others that are a little more complicated. So let's find a prime number that goes into 12, 20, and 8. Well, the prime number that goes into all of them is 2 because they're all even numbers. 2 goes into 12 6 times, 2 goes into 20 10 times, 2 goes into 8 4 times. Is there another prime number that will go into all 3 of them? And the answer is yes. They're all even still, so they can be divided by 2. 2 goes into 6 3 times, 2 goes into 10 5 times, 2 goes into 4 2 times. Now, is there anything that goes into 3, 5, and 2 besides 1? And again, the answer is no. That tells us that our prime factorization, again, is finished. So the prime factorization would be all of the numbers that are on the outside. So your LCM would be 2 cubed times 3 times 5. Well, 2 cubed is 8. 8 times 5 is 40. 40 times 3 is 120. So your LCM is 120. Notice when I did my multiplying, I did 2 cubed first, then I multiplied it by 5, then I multiplied it by 3. Remember, multiplication is commutative, which means that you can multiply it in any order. Okay, here's the last one that has a little bit of a catch to it. For 6, 9, and 12. Do your factor ladder. The first prime number that goes into 6, 9, and 12 is 3. Well, 3 goes into 6 2 times, 3 goes into 9 3 times, 3 goes into 12 4 times. Now, at this time, there is no number that goes into all 3 numbers. So what we want to do is see if there's a number that goes into 2 of them. And the answer is yes, there is a prime number that goes into 2 and 4. They are both divisible by 2. So 2 goes into 2 once, 2 goes into 4 twice. And then all you're going to do is bring down the 3. You don't do any division with it. Now, if you look at the numbers that we have on the bottom row, there is nothing that goes into 1, 3, and 2, which means we have finished the factorization. So now we can find our LCM. Our LCM is 1 times 2 squared times 3 squared. Well, 2 squared is 4, and 3 squared is 9, and 4 times 9 is 36. So your LCM is 36. So when you're finding the LCM of 3 numbers, find all the prime factors of at least 2 of the numbers. Bring down the number that you don't use, that is not being divided, then find the product of the outside numbers. That concludes our lesson for today. Please take note of any questions you have, and we will go over them in class tomorrow. Have a wonderful day.